Peter Beak, founder and CEO of Rocket Lab, has shared latest update on Neutron Rocket on 2nd December. Among the big names in private space industries like SpaceX, Blue Origin and Virgin Orbit, a New Zealand-based company, Rocket Lab is giving them a run for their money when they announced the Neutron Rocket for first time on 1st March of 2021. Neutron Rocket is the latest reusable mega constellation launcher, being developed in a unique, better and cost-effective ways. Today we will discuss about Rocket Lab's Neutron Rocket in detail. Peter described it as how a rocket should look like in year 2050. Welcome to Tech News. Our topic for today is Neutron Rocket. What's different about Neutron Rocket is how it's going to be built. Neutron is the successor of Rocket Lab's very successful Electron rocket. With its carbon black colored body, the rocket looks very different from any other rocket, and the beauty of the rocket comes from the materials and the process used in the manufacturing. Rockets have always been made in 2 or 3 stages stacked vertically. The top stage is lifted in space, using the bottom stages as thrusters. 90% of the rocket weight is used to lift the top stage outside atmosphere, and after this, bottom stage become useless. In top stage also the fairings are thrown away, and after payload reaches the orbit, the top stage becomes useless. Spacex is the first company, which was able to re-land the bottom boosters back. Those boosters are then used again in the next launch, to lift the new top stage with fairing and payload. But Rocket Lab is pushing this reusability further. Neutron Rocket is also a 2-stage rocket, but built very differently. The complete rocket is made as stage 1, and instead of stacking stages vertically, the second stage carrying load is hanged inside the stage 1. This let them bring the whole rocket back to landing site along with fairing, and the complete rocket will be used in next launch, to lift the new second stage with payload. The fairings are attached mechanically to stage 1, and opens up like a flower. Stage 2 is then released in space, and fairings are closed and brought back with stage 1. Since only the upper stage is disposable, they have adopted various methods to keep the cost of second stage as low as possible. Rocket Lab claims that their second stage is the lightest ever built, and hanging the second stage inside stage 1 creates the required tension to give rigidity to light and thin walls of upper stage. Rocket Lab's main focus is reusability and cost reduction, and very few are able to achieve this. Neutron is smaller and wider than Falcon 9 rocket, and in performance they are almost same. Rocket Lab's Electron development has played a major role in achieving this. With Electron, they have already proved that carbon composite is ideal choice for rockets. When SpaceX is ditching carbon composite and using stainless steel to build Starship, Rocket Lab have chosen to use carbon composite to build the whole body of Neutron. In their experiment they showed how weak stainless steel and aluminum is, in comparison to carbon composite developed by Rocket Lab. Carbon composites are expensive and takes too long to manufacture, and to tackle this, they have adopted automated fiber placement. In metallic 3D printing the speed is measured in millimeters per minute, but with their automated fiber placement technology, they are able to achieve speed measured in meters per minute, which is at least 100 times faster. With this tech they are able to reduce the expensive cost, speed up the slow process of manufacturing carbon composite, and will be able to get the game-changing weight reduction in rocket weight. With reduced weight, the fuel required to propel the rocket will decrease drastically. Focusing on orbital flight, they have developed the Archimedes Engine. Since they are able to reduce the weight of the rocket, the load exerted on engine is much less, and Archimedes can be used several times at low stress and with very high margins. Without even pushing engine to absolute maximum, the Archimedes will be able to generate 1 meganewton of thrust. And it's not the thrust but the specific impulse that is ISP of a rocket engine, that describes the efficiency. It's sort of like engine's fuel mileage and is measured in seconds. With over 320 seconds of ISP, Archimedes is among the top performing rocket engine worldwide. Apart from engine and structural composition, the main problem with reusability and re-entry is atmospheric thermal pressure. It's the extreme heat and pressure that rocket faces while re-entry. Rocket Lab is able to remove this thermal load with its design. Neutron has a very wide base which is fixed to the body. The second stage is super light and hanging from payload separation plane. The outer shape of the rocket is single body, continually decreasing from wider bottom to smaller top, just like a bullet. So as the rocket re-enters the atmosphere, the pressure is decreased along the vehicle, and avoids any shock wave attached to it, using this shape to its advantage passing through the atmosphere. Trajectory adjustment of the rocket is done with guiding wings called canards. And during re-landing, it doesn't need any infrastructure to hold the rocket, as it can stand on its own due to larger base. After the re-landing, the fairings can be opened again, a new stacking stage with payload is put inside, and Neutron is ready to launch again. Rocket Lab is developing Neutron in full force. Archimedes Engine will breathe its fire by next year, and by 2024, they will be able to launch this cost-efficient, 100% reusable rocket. Rocket Lab is trying to do something extraordinary with Neutron, and shine among the giants like Spacex and Blue Origin. Thank you for watching. Please like this video and subscribe to our channel. We bring you all the latest news in the tech world.